So welcome back everyone. In this video, we are going to actually model the equations that we have created in the last video in the Simulink platform. And as we have already seen, the variables and their corresponding meaning. And also as we have to give some values to these parameters, this is a list of values for a DC motor. And all the values are in SI unit, so you can calibrate accordingly, or you can change also if you want to play around. In the last video, as we have seen, we got two equations. The equation 1 is for the electrical part, which we got through the Kirchhoff's law, and equation 2 which we got through the Newton's second law. And now we are going to try to model this two in the Simulink platform. Once we got these two equations, the red variables are the parameters which are constant, and they will be represented by a gain block in MATLAB Simulink. And for the integration, we are going to use the continuous integration, which is represented by the 1 by s block. So if you pass the derivative signal, it will give you the, like if you pass the di by dt, the integration block will give you I value. And for this requires some initial conditions. And in this case, we'll only try our initial condition by 0, 0. You can take initial conditions according to you want. Start creating the model. But before creating the model, we need to assign some values to our parameter values. For that, we need to write a MATLAB script, a very small one, which will just contain the values of the parameter. So like any MATLAB script, we'll start with some basic commands like CLC. Well, I have fast forwarded the previous, just the adding the values to the parameter part so that you can just see the method, and that's it. Now we'll save this file and call it parameters of DC motor. Well, now the parameters is saved. Now we can just run it and we'll get all the values here. Alright, so in the next step, we're going to open the Simulink platform. The Simulink model has been initiated. It's a blank model, and we'll start from the very basic. And these are the two equations we got before. At the first, we'll focus on this equation, the electrical part, the equation we got from the Kirchhoff's law, and we'll try to model the part which is inside this bracket, which is just consists of some addition. So for that, we'll go to library browser and we'll go to add. So we got one add block, and in this one, we'll have 3 ports. Yeah. Now we'll assign the variables to it. This one will be UA. Alright. And what else we know? We know that this value will be I, the current, and this value will be the gain. So now we got everything. L into UA minus RA I minus K omega. So this will be for di by dt. Then we'll go here and we'll get the integrator block. So now if we integrate di by dt, we'll again get I. So what we can do is we can get this I, and I can just connect it back. So like that, this is a loop. But now I still haven't got omega, which I got for the mechanical part. And for the mechanical part, we'll do the same thing. Now this will be dw by dt, as you have modeled this part, and we'll get dw by dt. And if you integrate there, you'll get w. Yeah. So we have modeled both the equations given here. This is for the electrical part, and this is for the mechanical part. So for the current, we'll go get it from here, joint, and for the omega, we'll go get it from here. So this is the interconnection between mechanical and uh, electrical part, which is given by this value of k. And get a scope. Yeah. And one important thing before simulation is you go to the model setting. In the model setting, you change the type of the solver selection to fixed set, and put here the fundamental step size as TS that we have. TS is the sampling time of the simulation, which you have defined before here in the script. So that is one important part, and then you can run the simulation. So after adding the scope, we'll go to stop time and change this to 300, and then we'll run our Simulink model. So finally we can see the values here. The blue one is the omega, which like they start from 0 and they go up to 1, more than 120, and the value of current, it stops at like something around 50. And that was it for this video. We created the Simulink model and run the simulation, which we can now get the sensor values. In the next video, we'll try to obtain the sensor values, and we'll try to introduce manual faults into the simulation of the model.